So now we jump to J.J. Thompson. I'm not going to quiz you on the names of these scientists or when they lived or anything. It's just kind of, I think, useful to have an idea of when these things were discovered. So this is back around 1900. J.J. Thompson discovered a smaller particle than the atom, and it was called an electron. The electron was negatively charged. It was much smaller and lighter than the atoms, and they found that it was present in many different kinds of substances. So unlike atoms, where you've got an atom of gold, an atom of copper, an atom of lead, and they are different from each other, they found this smaller particle, an electron, that was present in pretty much anything they could mess around with, the electrons, and they were the same. They're much smaller than an atom. They'd have to be at least a little smaller than an atom if they're part of an atom. And they have a negative charge. Well, they knew that atoms had overall an electrically neutral charge. So if you have negative particles in there, there must be something positive in there. So Thompson came up with a plum pudding model of the atom. Plum pudding doesn't mean much to us. It's a British thing. And it's really, the closest thing we have is probably a blueberry muffin. So you've got this, cake and blueberries are scattered throughout it. So his model of the atom was that you've got this, I'm pointing in the wrong place, that you've got this sphere of positive charge. He didn't know what that was. He says there's got to be something positive, so maybe it's just this big, it's mostly positive, but then we've got these little negative things. It's a very crude idea, but you got to start somewhere. So it's a plum pudding model of the atom. And then Rutherford was doing some experiments. He was trying to confirm this, but he ended up disproving Thompson's model of the atom. So he did this experiment where he took a piece of gold foil, very thin piece of foil, and he bombarded it with alpha particles. Alpha particles are very, very small particles, but on the size of very small atoms. And they could detect these with this band around here that would give a little glow whenever one of these particles hit it, so that they could see where those particles were going. And they found that most of the particles went straight through the foil, and a few got bent a little to the right or to the left, but a few of them basically bounced off the foil. And that's not at all what they expected. They expected the particles to go straight through because they were testing Thompson's plum pudding model. So there was this charge, this positive charge sphere with these little negative particles in it. So they expected that these alpha particles would just go straight through and nothing would really happen to them. But what instead they saw was that they bounced back. And Rutherford said this was as surprising as if you shot a cannonball at a piece of tissue paper and it bounced back and hit you. That's how shocking this was to them. Because they were convinced those particles were just going to go straight through. But some of them bounced back. It was just craziness. So then what on earth are those particles hitting that's causing them to bounce back? Well, this led to the nuclear model of the atom. In the nuclear model, we have a nucleus in the center. So Rutherford's nuclear model of the atom, or theory of the atom. So from the results of that experiment, they theorized that the nucleus was where most of the matter, most of the mass of the atom was, and all of the positive charge. So instead of the positive charge being distributed all over the place, the positive charge is concentrated in the middle, and that's where most of the mass is, and then you have some electrons in the outer part, but still the atom being mostly empty space. But this nucleus here was very, very dense, very massive. And so when things hit the nucleus, they would bounce straight back. If they missed the nucleus but were close, they would be deflected. And if they were far from the nucleus, they would go straight through, like in this picture. So some of them got deflected. If you scored a direct hit, it would bounce back, but most of the particles went straight through. And so this theory explained the observations that they had. And so then, people go on and test the theory some more. So we've got electrons, which are negative, and this led to the idea of protons. Protons are positively charged particles that are inside the atom. The protons are +1, the electrons are -1, and so Rutherford says, well, there must be equal numbers if the overall charge is 0. This is not a scale model of an atom. Just to give you an idea of the size of the nucleus, if the nucleus was the size of a green pea, little green pea, and you set it on the 50-yard line of a football field, the edge of the atom would be at the goal line. So little pea, imagine, big football field, pea, 50-yard line. The atom is a sphere that would extend all the way to the goal lines on each side. Almost all the mass of the atom is in that little pea. And what's in the rest of that space? A few electrons, just going around. Atom is mostly empty space.